This is question 5 from the SACE Stage 2 Physics course companion from subtopic 3.2, particle wave duality. Here we have a metal with a threshold frequency of 6.45 times 10 to the power of 14 Hertz. First we need to calculate the work function in electron volts, then the maximum kinetic energy of the electrons that are emitted when light with wavelength 410 nanometers is incident upon the metal. So part A is fairly straightforward. We're calculating the work function. We know that the work function is given by h f naught, where h is Planck's constant and f naught is the threshold frequency. Planck's constant is just 6.63 times 10 to the power of minus 34. Threshold frequency from the question is 6.45 times 10 to the power of 14. Substitute that into our calculator and we get 4.28 times 10 to the power of minus 19 joules. The question wants it in electron volts, so to convert joules to electron volts we divide by the charge of an electron, so that will be 4.28 times 10 to the power of minus 19 divided by 1.6 times 10 to the power of minus 19 electron volts, which ends up being 2.67 electron volts. Now we need to calculate the maximum kinetic energy of the emitted electrons when light with a wavelength of 410 nanometers is incident upon the metal. So here lambda is 410 nanometers. Like before, we're using the formula, the EK max is HF take W, so we need to turn our wavelength into a frequency. That's easy enough. So from before we have V F equals V on lambda, which is 3 times 10 to the power of 8 on 410 times 10 to the power of minus 9. And if we substitute that into our calculator, we get 7.32 times 10 to the power of 14 Hertz. And so now the kinetic energy is easy enough. HF, so 6.63 times 10 to the power of minus 34 is Planck's constant, multiplied by this frequency, 7.32 times 10 to the power of 14. Take away our work function in joules from before, so that will be the 4.28 times 10 to the power of minus 19. Put it into the calculator, and we get 5.73 times 10 to the power of minus 20 joules. And there you have it. That's not too different from some of the other questions. The threshold frequency and work function is easy enough. Make sure you convert frequency, calculate the frequency correctly from the wavelength using all the right conversions, but aside from that, there's really not much to it.